Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on my fourth interpreter. So let's take a look at what we've got so far. So if I go into here, I can just do cargo run, and then provide a file, and alright, fizz so it just prints out fizz. Let me actually take a look at what we have. So we can do simple stack operations, like this, and then the dot will just print it out. So let's try cargo run, that's not 4, and there we go, 35. So that's 15 plus 20 is 35. Pretty simple. And we have multiplication, division, all that fun stuff. Okay. And we also have words. So you can define a word like this, and it's like a function, kind of, is a way to think about it. Hey there, how are you doing? Not sure exactly how to pronounce that. Probably told me before, I don't remember. I do apologize for that. But yeah, so you can call this, and then that's how you define it, and you can call it, and it will do whatever is defined in there. So 6. Yep, and that is correct. And that is pretty much all that we have, I guess, really, right now. And then we have a few other things for outputting, such as a new line. And we can also output strings. So we can output hello world. And then it automatically puts a new line at the end, so we can run that, and there we go, hello world. So that is pretty much what we have right now. Let me open the main.rs file. And let's see. So, alright, so right now I want to get conditionals working, and then I will add, try to implement if statements, if else statements. So yeah, this is basically the way that it works in Forth. So you have a few different operations. So, yes, you have less than, greater than, and equal. So that is pretty simple. Let's see, where does it make sense to add this? I suppose just after here. Less, greater, and equal. Okay, so that is the enumerator, and then we can very easily parse this if we... let me go down here first. I actually should move this up. Simply because I want to modify this part first. So, put it right up here. There we go. Alright, so, I can just go ahead and do this, and we have less than, greater than, and equal. Okay. So let me change this. Greater and equal. I mean less. Okay. So that looks pretty good then. So now we can, that's the whole lexing that we need to do. Tokenize. So yeah, 15, 10, equal. And then it outputs it. So, if we look at the specs. True is -1, and then false is 0. So that is what we'll push. Really, anything that's not 0 is considered true. But when it's done like this, it will push -1. That is like the spec for true. If that makes any sense. So that's basically what we need to do. So when we encounter one of those, let's see. Okay, we encounter one of those. So less, greater, and equal. Then we can go ahead and do stuff. Alright, so it should not be too difficult. Should not be too difficult to do. So let's do equal first, because that will be the most straightforward. So basically, we just need to pop. Let's see. It's self.pop. And then b equals self.pop. So we pop them both off, and then we just compare them and push the output of that. So self.push, a equals b. And we can't do it exactly like that because it's supposed to be -1. And this is just going to push 1, I believe. Or it might actually not work. I might not be able to do that. I'll go run. Let's see. So, yeah. Found bool. Alright, so can I do this as I32, like this. Alright, we get 0. So, let's make them equal, and I think it's just going to be 1. It is 1, so we want it to be -1. So we can just do, actually, I think we can just do the negative of this. So times -1. Something like that. Yeah. And we get 0. Okay, so that's not quite right. Is that not how you do it? Maybe I need to actually wrap that up still. Alright, and let's see. Integer and bool. Alright, yeah. So we can do as I32 times that, because this is already not 52, so that's all good. And mismatched. That is okay. Okay, and there we go. So -1, there we go, that is what I wanted. And then if they're not equal, it would just be 0. -0 technically, but that's 0. So, yeah. So that is pretty much all that we need for that. So greater is going to be quite simple, or quite similar. Bam, there we go. So, basically, so I forget the order that it does it. So that checks to see if the second item from the top of the stack is less than. Alright, so let's look at greater. So greater, the second item, which is going to be B, is greater than. So it's actually going to be BA. And let me also change it here so that it is consistent. And then this is pretty much the same thing, except that way. So I think that is how it works. So let me try to build that. And then we could try to do greater. And let me make this 11. So that should be false. Okay, that is false. And then if I make it 9, or yeah, there we go, 9. Then we run it, and whoops, my bad. That's not gonna work now. Okay, now it is -1. All right, so that is right. If I do the same thing here, 10, 9, greater dot. Whoops, I did that wrong. Yeah, it's -1. So that is actually perfect. And then we can swap it around, and it'll be 0, and then that will be -1, and if they are equal, same thing, 0. There we go. So now we have conditions. Conditionals. Alright, and then, yes, we could do these as well, and or an invert. That should be pretty easy. So it's not like, yeah, alright, perfect. So and or an invert. So that should be quite easy to implement as well. I should probably make like a function for these. Well, they would work as a macro as well. I'll worry about that later. For right now, I just want to do this. So I'm going to put it up here. So and, or, and, what was the other one? Invert. There we go. So let's go ahead and do that. Invert. Don't remember exactly what invert is. And, alright, and if we go up here, and, or, and, invert. Okay. So now we can actually handle that in here. Wait, that's a rock. I can't do too many actually. And, or, invert. Okay, so I will implement it in here for now. Let's try and. So basically, we're going to take the two elements. Yeah, same thing essentially. Let A equal self.pop. Let B equal self.pop. And then we just want to self.push A for B and A. B and A. There we go. Is that how I want to do that? Actually, is it and? It's gonna be that. Alright. It's like that actually. So let me do that and then do the same thing here. So as I32 and then times -1. Okay, so then we can do and. So let me just push 1 and 1 and then and print that out. And alright, we actually have some issues. Like the bool found I32. What do you mean? Okay, because they are those. So yeah, it's actually and like that. Yeah. Alright, -1. So that means it is. They are the same. And then that is 0. And then if it's 0, then it is 0 still. Yeah. Alright, because yeah. That's how and works. Yep, pretty simple. Alright, so or similar again. Similar yet again. Okay, and then this is just or, like that. So I can do or. So if it's either of them, it's going to be true. And it is. And then that will be true as well. But this will be false. And there we go. That's all working. So these are pretty simple. So what is invert again? Is that just... invert just basically takes it and then makes it 0. Yeah, okay. So it turns true into false, essentially. Oh yeah. But actually that is a thing. So you have 2, and then you invert. It becomes -3. So it's a little strange. Yeah, you get incorrect results with arbitrary numbers. Okay, so let me grab this. So basically, for this, so -1 invert becomes 0. So basically, I think what we need to do Not any of that. We want to, we only need one actually. We only need the top of the stack for this one. So we'll have A. And then it is already 932, so we don't need to interpret it like that. Times -1. So is that how we want to do that actually? So we get 0. I did not use invert. So that should make it -1. Yeah, but that doesn't work with 0 because it is 0. So do we need to just subtract -1 actually? So we get 1. So that's not right either. We need to add -1. Yeah, there we go. It becomes -1, and then if we have -1, which I don't think we can actually, we can't do that, so I have to do 1, 1, or 0, 1 minus, like that. -2. Okay, so that's not right. So how is it done exactly? So so we want it to be 0. -1 invert is 0, and 0 invert is -1. Yeah, so obviously that won't work. Basically, -1 plus 1. Let me look at how I did it in Go. Which is the fourth interpreter that I wrote in Go. So let me just look at invert, wherever I handle that. Okay, okay, so it's actually negative of that. -1. Okay, so I can just do obviously -1 like that, and there we go. So that is how that is handled, and that gives expected results. Okay, so that will invert. And if I do 5 or something, it should become -6. I don't want to subtract. -6. All right, and we can see it will do the same thing in here. -6. All right, perfect. All right, so I think we are ready for if then. If then, okay. So we can pretty easily add the things for this. So these can only be in Word definitions. So we'll just write a simple one. So basically 0, and then if, then we'll just output test. Then. So that is how that will do. So if the top of the stack is true, then it will just say test. Otherwise, it will just pass. Essentially, is what that will do. So this is false right now. Let me just add the lexing for that. I'll just put it here. So we have if and then, and then we can actually lex them. So yeah, then I'll just go down here. If and then, there we go. And I need to actually change these to be if and then. All right, perfect. Then, so let me add those down here. All right, let me just yank these. If and then. Okay, so let's think about how we want to handle that. We do want to know, we have to know if we are in a word, because otherwise it is not valid. So like if we try to do 0 and then if test, then it's not going to work, because yeah, it's not a word essentially. So we need a way to check that, and we don't have that at the moment. So I'm thinking if we go to the interpreter structure, yeah, the interpreter structure, and we actually just add in Word essentially, and this can just be a boolean. And then when we initialize it, it's actually down here. Let's see, where do I actually initialize it? Yeah, right here. We can just do in Word, which is false by default. And then at the end of this interpret tokens function, we want to always set self.inWord equal to false. And then if we actually call one of the words, then we want to just set it equal to true when we do that. So we'll need to add a block here, like this. Then yeah, we can actually, before we interpret it, we can use self.inWord equals true, and that'll set it equal to true. So then we can check. So if we encounter an if self.inWord, then it's all good. Actually, let's do not. If not, then we will just end it and say can't do that. Expected word to be in Word essentially is what we are expecting. Otherwise, let's just print line, and we'll just print if, and we can try that out. So we do have an if in there. Undefined word text. Yeah, so that's not going to work because That's a little weird. Now that can't be a space there, that's why I did that. If. So we did get if, and it worked properly, but if we get rid of this, and we do if, then it will not work properly. I expect to be in work. Alright, so that is actually all working, so I can undo that. So, print if and when we get here. So basically what we need to do is pop off the stack. Yes, we can do, let a equal self.pop. And that is going to be our value. So then if a, so if a, if not a, then we just want to skip. So we can just pop until, yeah, we can do a similar thing. Otherwise, we want to actually just continue. Continue. Yeah, just like that. I don't know if we can use continue. Maybe. I don't know, we'll find out. Let's do that. So if it is false, then we want to skip over it. So how could we go about doing that? We need to basically pop until it is a then. So we can do a similar thing to what we are doing here. So something like this. Except we just want to get rid of that amount. So we can make, yeah, we can do this. And then in here, we'll do this. And we don't really need a token vector, but I'm going to use it anyway. So basically, yeah, we can just make it a regular vector. And we're just going to collect all of these until the token is there. So while it's not, we will collect all of that, and then we'll just split off. I think something like that should work. Let me build that actually. Expected bool, found that. Okay, yeah. Let's see. So if a equals 0, so we want to check that. Okay, empty stack. So yeah, because actually, why is it empty? It should not be empty. I might have messed something up. Let's see. So that is on 111, and let's see. So we're trying to pop, and it is empty. So it does pop, right? I need to make sure of that. Because I remember some confusion with this before. So if we do 0, if test, then and call foo, it's okay. It doesn't do anything. But if we make it 1, then call foo, it does print out text. Alright, so that actually is valid. So we have this here. If we make this 1, what will happen? It's still empty stack. So why is it? It does print out text though. But then it becomes an empty stack. So I'm not sure why that is exactly. 5. I put a 5 there. I put a 5, put 4. So why is the stack becoming empty? Quite curious. So if I don't have if, and I just do this, and get rid of them as well, then we just get text. Okay, so yeah, we don't get stack problem there. So it is definitely with the if. Are we popping more than one time? You know what? I know what it is actually. It is with the then. Let's see, where is the then? Yeah, because we're popping it off here, and we don't want to do any of this for then. We don't really ever want to encounter a then. Alright, let me try this. So we actually are going to encounter the then. But then it does work. And we can make that 1. Or we can make it, well, we can't really make a negative 1 without. We can do 0, that, minus. There we go. Now it's negative 1. And it works. Okay. If there's anything other than 0, it will be that. Alright, so that works. We now have if. So when we encounter this, though, we want a way to check if there is an if. So basically, we need to do this until there's one right after that. Let's see. We can do when plus 1. And then we should not encounter then. So if I just print 1, then, like so, and run this, we should not get it. We do get it, though. So, why is that? That's a little bit strange. Then, if I do, we still do that. Plus 2, it should not be that. So I don't know why it is. Am I doing this wrong? Tokens not split off, yeah. So this should be modifying it. Just remove up to that length. Then, okay. So why does it not do that? Okay, so we have the vector tokens, which we don't need that necessarily. Could we just do the .len of this? I suppose that would work as well, instead of making a whole variable for that. Let me try that. Token.split off. That dot len, like so. Let me try that. Okay, so that's collect, and we need to give it a type. So vector of tokens. Okay, actually needs that as well. And it does not like that. Can I just put here? Because well, this is actually, yeah, that's not gonna work. So why does it want so many of those? I think that it is not right. Yeah, so that's not gonna work actually. Let's do it this way. Okay, so why does it not split off properly? What if I do tokens.len? That should just get rid of all of it. Actually, I think the reason is it's with the word. That could be it. Token make is unused, yeah. But we still do that. So we're not actually splitting anything off. Which is not ideal. Because we do want to be doing that. This needs to be that. I don't remember exactly why I had it like that before. I think that. Yeah, it still doesn't work. So, it's not like a big deal, but it's just for error handling, we want to be able to detect if we have a then without an if, essentially, is the point. Tokens. So let me look here. So tokens. Let me actually do some debugging. So let me print line. Let me just print the tokens.len. Like so. And then do that after as well. And it should change. We don't actually print it. So do we not encounter this? Oh, you know what? We do not, because we are not skipping it. That's actually the whole problem, isn't it? 3 and a 1. Okay. So that actually is working. But we still encounter that, because we need to do +1. +1, like so. And then we don't encounter the then. Okay, but I suppose we still do encounter it, we still do encounter it when it is true. So, so maybe there was not really a point to that. Because here we still need a way to check it. So how can I do that? Let me think. So we continue here, and if we encounter then, I don't really want to just set a flag in the, like a Boolean value in the interpreter, because that's kind of lame. Alright, well this is good enough for now, and I will come back to this. So we don't really need to print anything here. We can just skip it. And there we go. It does actually work though. So we can put whatever we want in here, 15, 5, plus, dot, and it'll print out 20 as well as text. And it all works, all fine and dandy. And I think we don't actually, I need to change something. In the, here, we print line. I just want to print instead of print line, so that there's not a new line by default. And you have to add that yourself. Because that is how it's actually supposed to work, according to this at least. Yeah, if we do something like that, test, and then we print 15, then there is just a space. But other than that, there's nothing else. Yeah, there's no space if we do that though. So no new line is what I am saying. Yeah, so I can just get rid of that. So I will come back to that though. We'll come back. So that's pretty good. Now we can look at else. So if else then, here's an example. Yeah, so basically we just have else. So if that, we do have then. That's not the end. So we know that and that is the end. So else, well here we could actually do the else here. So we could do this. Put a print test. Otherwise it'll just print 15. Like that. Yeah, I think that is good. So let's lex else. So I can just go right after it. Else, like so. And pretty easy. Here we can just add else. Like so. And then we actually need to update this. Okay, and now coming down here. We can add else after the if. Where is the if? Right here. So it is quite similar. Whoops, no, to do that. Quite similar to this, really. Except, let's see. Well, this we want, well, it is not that, and it is not, b does not equal tokens, oops, tokens else as well. We need to be checking that. So, yeah, if I just do something like that, like that, I think that should do it. I run a test. It does not, yeah, so we need to, what is this? Yeah, tokens else. Then it's empty stack. That is alright, because we don't want to pop it on when we encounter that. Yeah, so actually, when it's false, yeah, we want to go to the else. But when it's true, we want to skip over the else. So that is something that we need to consider. So what is the way to do that? Well, we do want to go until then. So we always want to do that. But we don't want to pop. We want to get the value that maybe then should pop it. Yeah, that could work. Like, so we could just peek the value here, and then once we get to then, actually pop it off. Would that break stuff, though? I'm trying to think. So, because if we have, say, we have if 5 plus, else 6 plus, then. So if we have that, and then if we call 10 food and print it out, we get a stack underflow because we need two numbers here. So 10, 1, 15. And then 0, 8, 8, 8, 16. Yeah. So it's gonna mess up the stack though if we do that. Because we actually want to pop it off here. So we need a different way of handling that. So basically, I suppose we could handle that in here instead. Where if it's false, we go until it is there. Okay. Until it's else, yeah. And then we actually just interpret the else. We just do that. Yeah. But if it is true, we want to go until it is, we want to actually be interpreting it. I'm trying to think. So what is, what's the way to do this? Cause, right. Yeah. So in here, if it is else, then this actually does work fine. So if it's false, it'll just go to else. And that is actually fine ending. We don't want to pop on else. A is not found in the scope, so let A equal 0. Sure. I'm going to do that for now. Test. Yeah. But if I make it 0, 15. So that's almost right. But yeah, I'm trying to think. So what's the way to do this? So we need some way to keep track of if it is true or not. And then, yeah. So like an if stack. So maybe we could have a secondary stack for that, where we push the value of whatever it is. So if it's true or false, we push that, and then we pop it off and we check. We could do that. I'm trying to think. So how would that work then? Because we still need to. Yeah, I suppose I'm going to do that. So let me just make another vector in here. Well, actually, is there just like a stack in here, or are you supposed to just use vectors or arrays or whatever? Q and stack. Vector. Yeah. So I'll just use a vector. That is all good. All right. So let me do. Actually, I'll put it up here. So this can be if stack. Is what we'll do. So we just push whenever it is there. We'll push onto here. We could just push a boolean, since it's only going to be one of those, and that will be a bit more efficient. So we could do that. Yeah, and then when we encounter if, we will just self dot if stack dot push a equals 0 is what we want to push. So then if it's 0, actually a does not equal 0 is what we want to push. So if it's 0, it will be if it's 0, it will be false, and if it's anything other than 0, it'll be true. So that's all good, I think. So I think that is what we want. And then in here, when we encounter else, we need to actually, instead of popping off that stack, we need to do self dot pop, or self dot if stack dot pop. And then instead of this, we just need to check if not A. Something like that. And I think that should be pretty close. Missing if stack. Yeah, because I don't actually put it in here, so this can just be a if stack can be vec new. Okay. Okay, and that will not work. Type option. Oh yeah. Okay, so we need to handle that. So where's that at actually? Let's just unwrap it for now. And 15. So we get 15. And if it's 1, we get test 15. So it did not work. Because we don't actually skip over the else. No, but it should still be fine. So why is it not to skip over? So I don't see why exactly. Does this mean to be or actually? No. That is too much issue. Okay, so if it's then and it's not, yeah, so that should be fine still. Then we're doing this. Here we are collecting. The +1 is fine. Otherwise we continue. You want to do this the opposite way. I don't think so. Okay, here's what we do actually. Yes. That actually makes sense. So we do want to do it that way. So now this way it prints out 15, and if it's anything other than 0, it will print out text. So I think that is all good. That is if else then. So we can actually implement the same thing that we have here because we have all the stuff for that. So is it 0? 0 equals if, yes, else, no, then. Alright, something like that. And we can do is, 0 is if it's 0. And then we can do the same thing with 1. And it should print out yes and no. I need a line break though. Just make it more readable. Alright, something like that. And yes and no. Alright, perfect. So that is all good then. Seems to be working. So let's see what is next. So do loop. So I could do that. Let me look at the other stuff because I don't remember necessarily all the stuff after that. So we do need a modulus operator as well. Yeah, so I can actually add that quickly because it should be fairly simple. So it is just mod. So that'll go right after division here, mod. Yeah, no, mod there, and we'll add mod into here, right after div. Mod, okay, and then we'll handle it just like all the others. Div. Whoops. Did not mean to do that. Let's see, where were we at? Div. Mod. And I think we can just do something like that. So let me actually try that. So if I just do, let's see, 9.3 mod and print it out. 0, okay. And then if I make it 10, it should be 1. Should be 1. Alright, and then 11 should be 2. And 12 is 0 yet again. Alright, perfect. So that is all working. We have modulus now. So I am quite happy with that. And yeah. So let's see what else. So what else do we have besides do loops? Then we have variables after that. So that makes sense to come after do. Yes. Alright, so that, yeah. So that's like memory stuff. So we're gonna have like a simulated memory. Yeah. Should be pretty easy. Okay. And then, yeah, we have arrays where we just can allocate space on the memory. And then that's pretty much the last thing, other than keyboard input, which is quite simple as well. Begin until, ooh, okay. I forgot about that one. Alright, could probably implement something like that as well. But let's go back up to the do. So I'm gonna go back up here. Do loop. And let's look at how it works. So we have, this has 3 different things, I think. Yeah, 3 keywords. So we have do, loop, and I. So I can go ahead and add those here. After the then, we have do, loop, and I. So I is a special thing that prints the current iteration, is what that means. So, do Waller2456 followed. Thank you, I appreciate that. Do loop and what was the other one? Yeah. So if we counter I, then it is if we counter loop, it is loop, and if we counter do, it is that. So maybe I should not be called I, because that is a little confusing, but it's probably fine. It should be fine. Should be fine. So now we can handle it. So let's look at how it actually works, because I don't remember. So let's see. So does it have to be in here? Yeah, it needs to be in a word. Okay, so it is similar to that. So just 10, and then this is the starting one. And then do. So do is going to pop off the 2 elements of the stack. And then it will decrement the second one, starting from the first one. I think is how that works. So yeah, we can just print I in here, and then we can loop, and we can do loop text. Yeah, so it starts at 0, and then it goes up until it is not, so it's equal to that, essentially, is what I'm trying to say. So that should be pretty easy to implement, I think. So let's go to the do. And I'm going to clean this all up so it all looks nice like how this looks. But not yet. So if, we'll just add that in here. Not after if though, actually after then. So we'll have do. I'm going to execute that, and then, yeah, like that. Whoops. Okay, do, loop, and I. So if we encounter I, we need to make sure we are actually in a loop so that we can actually output the current iteration. So that is quite important to do. So let me think about how we're going to handle this. I think we can, yeah, we can actually, we can do a similar thing to what we're doing here, where we collect all the tokens. Yeah. So we do need to pop off first. So, let A equal pop, self.pop, as well as B. Okay, so we can do that. So we have the A and B. So that is the starting number is A, and then the target number is B. And then we want to actually get all of these tokens, all of the tokens, and these are going to be all of the loops. So we need to go until we encounter, whoops, till we encounter the loop keyword, and then we have all the tokens, and we just can constantly be calling upon them. Yeah, I think we could do something like that. I think that would make sense. Yes, we're gonna call it like recursively, call the function recursively. And we do actually want to split off all of these as well, I think. Yeah, that's probably a good idea. And then, yeah, we'll just do self.interpret tokens, and we just want to interpret the token back. And what else do we need to actually pass there? This seems pretty cool, even though I barely understand what's going on. Well, yeah, I know how you feel. I oftentimes watch streams and barely understand what's going on. This is not too complicated, though. I think the most complicated part about it is understanding the Rust, because Rust is a bit of a complicated language. Yeah, so where do we call this, actually? So we interpret, yeah, so that's all good. Let's do .clone as well. Where is the do? Yeah, so we'll just clone this. Clone, okay. So we want to do that, but we want to keep doing this. So basically wall, I think we do wall A is less than B. We want to do that. I think so. And we also want to decrement A. A minus equals 1. We want to actually add to it. Something like that will be pretty close. It needs to be mutable as well. Mutable. And it does compile. Okay. So let's try to make something here, and we'll just have a simple do. So we'll do the same thing that we have in here. So do I dot, and we don't handle the I. So let me actually just print 1. And then loop. And let's see what happens. We don't ever call it. It's called 3. And we do print out 1. And how many times is that? That is 10 times. Alright, so that is actually what we wanted. So if we make this 9, and we get it 1 time. Alright, that is actually perfect. So it looks like that is working. The only problem is we don't handle the I. So when we encounter I, we need to know if we're in a loop. Yeah. So how can we do that? And we also need the current loop, current iteration of the loop. So what if we make another structure? Yet another one. And I will put it right above the interpreter. So struct loop. And then this is going to have current iter, which will be 932. Okay. And then we'll also have let's see, what else do we need? We also need is loop, in loop. That'll be a bool, and then that can actually, we can place a loop into the interpreter. So actually we'll put that right here. Yeah, so we'll just have the loop is loop. So we can always check in the loop if we are or not, and then we can also get the current iteration. So then we can initialize that here. We can do oops, loop equals loop, and this is not very clean. I need to make a new function like this for it, but that's okay. It's okay for now. So current iter is going to be 0 because it's none, and then in loop is going to be false by default, and then we will set it equal to true when we encounter a do like this. And let me actually not do the plus one, and here we'll just do self.loop.inLoop equals false, and then up here we can actually set it equal to true when we encounter it like this. Something like that I think will work. So then if I can do if self.loop.inLoop equals true, or we don't even need equals true, and we'll print line in loop. Otherwise, else we will print not in, and I can test to see if it actually works. Let me compile that, and unknown field. So we do not have that. So what is the deal with that? So interpreter, did I not add it properly? We do have a loop in there. So what is the issue with it? Okay, yeah, because this needs to be a bit different. It needs to be like that. And it still doesn't know what loop is. So why is that? Oh, because it can't be. I'm stupid. I'll just do current loop like that. So that is what the issue is actually. That is what the issue. So current loop. And that is fine because it's a capital, so it's all good. All good there. And then in here we need to just change wherever I put loop. Let's see, where is that at? That is in the do. Yeah, so cur loop. Cur loop and cur loop. Alright, and then I can compile that. And let's see, so field in this struct is never read. But we are going to read it. Just not yet. When we actually work on it. But if we put an I in here, it's just going to print something out. So we have in loop. That is perfect. But if we place it on the outside, at the end, it's not in loop. So it actually seems to be working. So then we can just, well, so we want to just throw an error here. No, actually, this one we want to throw an error. So we'll just panic for now, for right now. Yeah, I can make it better later. We'll just panic and say, error, I cannot be outside loop. And then here we will just self.push self.curLoop.curIter. Current iter. Let me call it curIter because that will be a bit more consistent. So curIter. CurIter down here as well. Alright, and let's compile that. And so does it work? Let's do I dot and just print out each iteration. And get 0 every time. Because we never set it. Yeah, I completely forgot about actually setting it. So, we want to set it to be a reference to A. Yeah, so that's actually what it needs to be. Self.curLoop.curIter equals A, like that. So that won't work yet, because that's not quite right. And we do need to change, we need to change this to be dereferenced, I believe. And we need to change here, current iter, to be a reference like that. And let's see, I don't know if we can do this. Okay, we need a lifetime. Okay, yeah, so that might make it a bit more complicated. So, what if instead of using the A, we use the current iter, and then it doesn't have to be a reference. I think that'll be fine, because I don't want to have to deal with the lifetimes right now. Don't feel like doing that. Yeah, so I would just change it back to how it was. So yeah, we'll set it equal to A, and then instead of working with A here, we'll work with self.curLoop.curIter. Yeah, and then we'll do this here. for loop, and we'll need to set it to be mutable as well. Yes, we will need to do that. Okay. So something like that is good, and this doesn't need to be like that. So what was I just saying? Yeah, it needs to be mutable. So I think, can we do that like this? Perhaps not. Actually, I think it. Let's see. Remove that. Yeah. So let me. Hey, let's get rid of that. Okay, and then we seems to work actually. So we can start at 0 and do that, and we actually get an error if we place I outside of a loop. Yes, and also in a function as well if we place it outside of a loop, it should fail. Yeah, I cannot be outside. So it looks like it is working then. So I'm quite happy with that. So there we go. That is actually a do loop. So let me go ahead and commit these changes actually. So I will just add everything and then implemented if statement and do loops. So I would just push that. 152 insertions. That is decent enough. So let's go back to here, open these back up, and let me make sure it actually went through. It did. So we're all good. So let's see what is next. FizzBuzz. So I think we can do this now. So I just want to make sure it works. And to see if there's any bugs. So fizz, I'm just going to copy exactly what this is. Fizz. Then, and then yeah, do buzz. Make this buzz as well. Like that. And then FizzBuzz. FizzBuzz. And that is actually a bit different. So, dupe, fizz, swap, buzz, or invert. Okay, so we should have all that as well. And do FizzBuzz. 25.1, do CRI FizzBuzz. If I dot then loop. Okay. Do FizzBuzz. So this should be FizzBuzz. And it did not work. Expected to be in word. So I could have messed something up. Where do we actually say that? Expected to be in word. So that's an if statement outside of a word. So, did I mess up one of the word definitions, perhaps? Or did I not set it properly? Yeah. Because I'm pretty sure I did not mess this up. Because it all looks fine to me. So, do FizzBuzz. Like so. Alright, so let me actually, let me do some of this. So, let me call fizz. And do we get the error there? Let me actually, then we get an empty stack here, actually. Because we don't have anything on the stack. So let me just put one. And try that. And it does work. Works fine with fizz. Buzz works fine as well. And then FizzBuzz. That does work as well. So, because, okay. I then loop. Can we not, you know what? The if could be breaking. No, it should be fine actually. I don't think that, I'm thinking it could be in the do loop, because of the way we're handling it, it might break if. But I don't think it should. Because that is when it fails, is when we call do FizzBuzz. So, I need to actually put a number. Yeah, so that is where we fail. So I'm assuming it's at this if that we have right here. So, what can we do about that? Or it could be, when we're calling this. Do. So we get to do. Let's look at do. And then we're here. We're currently not in an if. But then we call FizzBuzz. And then we call fizz from there. But no, we can call it from there. So it could just be what's in the do. So let me actually test it by making a simple thing. Where we have a do loop and 0. And then do. And we'll have a loop there. And then we'll just have an if in here as well. So we'll just do one if, and we will just print out I. Okay. Yeah, so let me try that, and then just call do. Expected to be inward. Yeah, okay. So it looks like that is where it's actually failing. We do print out the 0. And that is fine. But then when we go through it again on the next iteration. And actually I know exactly why. Yeah. Yeah. Okay. Yeah. All right. So when we call it in the loop, since we're calling it recursively, at the end we do this. So what we can do instead, no, actually that's not where it is. It's in the loop or in the if else. So wait, where do we set? I think it could be in. Yeah, it is with this actually. So we need to actually set that. Instead of at the end, we can set it when we reach a semicolon, like that. And I think that should have pretty much the same effect. And then it actually does work. So let's try calling do fizz buzz. And it should. Alright, so it almost worked. Ooh, it's a little strange. Did I mess up a new line actually? Do CRI. Actually, is it because of this? Huh. We do get some extra new lines. So I don't remember why exactly. Let me copy some of this stuff into here. Alright, so we can't. Actually, that does work. So if I run that, so we do get that. So it does work here. But why is that? Okay. But it is working. This is actually correct here. So, because 1, 2, and then 3. It does print out the 3 as well, though, so it's not working. So why does it do that? Yeah, that's a little strange. Not exactly right. So, is it something to do? Yeah, it's almost working. It's almost working. Is it something to do with the loop? The if statement's in the loop again. Let's see. So, do again. And then let me set this actually equal to false, and it should not print anything. And it does not. So that is fine. Do these guys. Alright, let me just do 3 in here, rather than 25. And, okay, actually we need to do 4. Alright, fizz, and then it prints out the 3. So, why does that happen? Did I mess it up? Swap buzz. Find mine 0 equals dupe if then. Let me look in Go, which is the 4th interpreter I wrote in Go, not very long ago, 2 weeks ago. And I didn't save it, so never mind. I can't even look at that. Because I think there was something I had to do with the fizz buzz different. I don't remember why though. It was something to do with if. If was different. I don't remember exactly. Yeah, but why is this not working? So this is just always printing the number, yes? Yes. Okay, so we should be skipping over. So is the invert not working? Instead of this, can I do dupe and a dot and see where we actually get there? So, let me make this and actually put a new line. Okay, so -1, -1. Yeah, this is the iteration. So we get -1 each time. We get true. But then there's no -1 here. But we get -2. Oh, okay. Let me get rid of the new line, actually. So why are we getting -2? Is my invert not working properly? That could be it. The OR could also be incorrect. Alright, let me actually call fizzbuzz. Just the regular fizzbuzz. Like that. On 5, for example. Yeah, 5, and then we'll print out the output effect. So, we get -2. So that's obviously not quite right. Okay, because that should be 0. False. Yeah, it should be 0. But instead it is -2. And 3 is going to be -2 as well. And then anything else is -1. So something is messed up. Could be either on the OR or the invert. So I suppose I could test that. So let's try, let's do 0 invert and print it out. What if I do 0, 0, OR invert? and then 1. So either of them, then it becomes 0. So that mod 0. Let me try that. So let me get rid of that one for now. So let's do 3 mod 0. Yeah, 3 mod 0. Because we need something else on the text as well. We'll do 3 mod 0, and then we'll do 3 5 mod 0. And let's see what it says. So it becomes 2. So why is it 2? That is a head string. Alright, what if instead of 3 I make it 4? Actually, could be with a mod function that is not working. Let me do 9 3 mod. Let's see, 9 3 mod. And I need to print it out actually. So we get 0. That is fine. That is 1. Okay, so I think that is fine. That order is fine. So it's not with the mod. Yeah. 3 mod 0 equals. We don't need this mod. So it equals -1. Ooh. So that's true. And then let's do invert. And it becomes 0. Okay. And what if we have 9 5 mod 0 equals invert as well? Actually, instead of equal, we do that. We do this, and then we do or invert. So we get -2. So it is somewhere in here. It is not working. So yeah, it shouldn't be -2. But let me make it 15. But they are both the same. It's still -2. But if they are not valid, then it's -1. Okay, so what is the output of this? Output of that one. So we get that. So it's -1. So that's fine. Reboodle followed. Thank you. I appreciate that. Reboodle. I think I pronounced that right. Yeah. So 15. -1. And that's right. So if we have -1, well, I can't actually just do -1, so I can just do that. 0 1 minus, and then do or invert on it, and that is where we get -2. Yes. Okay. So we are starting to figure out where the problem is. It could be the way we're handing it over. Yeah. Because we have, yeah, if we do that here, we can just actually put negative numbers into this one. -1, or invert. We get 0, not -2. So that is actually the issue. -1, or dot. We get -1. And if we get rid of the invert here, we get 1. Alright, so that is not what we want. Ooh, actually, I know exactly why. It's a problem with the arm as well. Or it's not. Yeah, because that should be... Actually, if I do that, then we get the -1. Alright, so I don't think we need to do that. Hang on, so this is -1. So, or... Yeah, alright, so we do... Yeah, we don't need it there either. So that is actually what we need. Now it should actually work, I think. Okay, still not quite. I did actually add some stuff that is making it confusing, which is down here. Alright, let me run this again. Test.forth, and 1 and 2, and then fits. Alright, but it did not print the extra number, so let me get rid of the... Let's see, where's the new line at? New line. Why is there so many new lines? I don't know. You know what it is? Yeah. It is because when we actually encounter the print, which is just the dot, we don't want to print that. We just want to print. Then, there we go. That is better. So now, we should be able to do 25. And it should print out the FizzBuzz. Okay. So we get that last one. I wish there was a new line here. So I can just do this. Okay. Now we can look at it a bit. So 24 is fizz. Okay, that is actually right. Yeah. So 3 fizz, and then 15 is fizz buzz. All right. There we go. That actually is working. So it's all working as expected. Yeah, that is pretty good. Pretty good. Okay, and let's see what else. Let me actually make this a like an example. I should probably make an examples folder. For now, I'm just gonna put in the source. But then I'll make a separate folder for that. Yeah, but not right now. And I'm putting the source folder. Yeah, slides.folder. There we go. So now I have that. I will keep messing around with test.folder. Okay, here's how we sound effect stack. Yeah, I get it. So variables is next actually. So that means we have to work with memory. Well, we're gonna simulate the memory using yet another stack. So that's how you define variables. So we can, let me get rid of all this, and variable balance, and then print out balance. So if we call it, here, show what happens here, variable balance, and then balance, this is actually the position in memory that is at, the location. Yeah, so you can actually get it if you do something like that. Maybe it's not like that. I don't remember how it is exactly. That's actually to change it. Yeah, to fetch it, we need to do at. That's my bad. At, and we get 0 is what it is, because we didn't set anything. But if we do 1, 2, 3 balance that, then it will be 1, 2, 3 is stored there. So that is how that works, essentially. So we are going to make, add another thing to our interpreter. It'll be yet another stack, but this will be memory stack, which will be another vector, and it will be i32 as well. Does it? But it needs to be actually unsigned. It needs to just be like that. I don't think it's going to be greater than that. Because it's never going to be negative, because it is actually an index. An index. Yeah, the value that we get is an index. But the values actually in here could be different. Yeah, so this can actually be that. It can be the same thing as this, because it's actually the same as the stack. Yeah, but the actual indexes are going to be different, if that makes any sense. It will make sense once I implement it. And then let's add the tokens for it. So yeah, we need variable and identifier. Ident is good. Yes, this is the ident, and this is the variable. Okay, so the ident is actually a word, sort of seen as a word. So we'll need to check that. So for now though, I will just add. So it is variable, and that becomes variable. Okay, so then we'll make it a word whenever we encounter something like this. So this will be treated as a word, and then we're going to check twice. So if it's not in the word hash map, we will check then in the memory hash map, which will be where all of those are stored. So we will need another hash map actually for that. So this is just going to be the memory map. Memory map. Which is collections hash map, like this. And we do have a string, but then this is actually the unsigned, because this is the index. Like that. Yeah, so I think that'll be pretty good. So this is how we're going to be storing the identifiers and their values. And this value will be the index in this vector of whatever you are trying to get. Yeah. So that is basically what we're doing. Makes sense to me, I think. Let me just make sure that's all right. Okay, so then we do need to initialize that down here. So we have yet another stack. So let me actually make this because we don't need to use the macro. New, okay, and then this will be vec new as well, but this is the memory stack. And then we'll have the memory map, which I will copy this instead. Memory map. Okay, so that should all be fine and dandy. So if we encounter the word variable, then we want to get the next thing. So let me see. So I added that right after I. Variable. Like that. And then basically, yes, we just want to pop, and then the next thing should be a word. So if self dot what do we need to pop? Self dot token. Yeah, actually, is it just tokens dot pop? Does not equal a tokens word, then we need an error. So because that means it was a keyword or something like that. So then we can just, for now, I'll just do this again. I'll change it later. I will just say unexpected keyword. And I think we can actually just print it out like this. So it is a bit clear what is going on. So let me actually make the name equal tokens.pop. So that is it. It's going to be an enumerator. And we'll put name there. And instead of pop, we will do name. Tokens word. Okay. And then, actually we can just match it. Match name. Yeah, like that. I guess I could just do my tokens.pop then. Okay, and then put this in here. So if it's anything other than tokens.word, then we're going to do this. Unexpected keyword, and we need actually the name. So can we get that? How do you get that? Not sure I remember exactly. Well, it doesn't matter for now. So I just will not put it in here. And then here, it is going to be tokens word. So then this also has the name. And then we are going to output what are we going to do actually? So that is going to be in the hash map what we're going to do. So yeah, we'll just set it equal to the current thing. So let me just do a hash map.insert. So self dot what did I call it? It was variable map. No, memory map dot insert. And we want to insert name, which will be a string. And then, yeah, so we're going to insert name. And we are also going to insert the length of the self.memoryStack.length. Okay, so we'll do that. And we won't actually, there won't be anything there right now. It'll just be empty. Yeah. We really need it to be 0 though. So we should probably 0 initialize the whole thing. But I don't know if we can do that. Yeah, actually I think we can. So instead of doing this, we can do the macro, use the macro, that. And I think it's something like 0 and then just the just be 10 for now, I think. I think that is fine. Maybe I should make it bigger. I don't know. I'll do that for now. And I think that will initialize it all with 0, which is what we want. So let me run this and see what we get. Tokens.pop. Yes, we need to actually pop front. Tokens.pop. Front. Like so. Some. Yeah, okay, so that can be like this. Name is not found in scope because we don't need this anymore. And then statement is not surrounded by a body. Okay, yeah, so we need to do this here then. Actually, I think I can just do it like that, and then it works. Okay, expected that, found that. Alright, so I think we do actually need a block in here. Alright, so let's okay, try into unwrap. Okay. usize. Yeah, so we can actually make that usize instead of that. Instead of a u16, it can be usize. That'll be fine. Ident. Okay, so we don't actually handle that, so I can add that quickly. So that can go after here. Ident. And yeah, I'll just do this to do here. Like so. And then, alright. So what problems? Undefined word balance. That is okay. Yeah, so that is what I was talking about here. So basically, yeah, so if we get that, it is here. So then we need to check the next branch. So if it's not in the word map, we need to check if it is in the other map. Otherwise, we want to panic. Yeah, so this way we'll do, I will add this here. I will do match self.memory map .get. Put the word in there again. And then that. So if it is none, this one is none, that means we actually do have a problem, so we can do that. Otherwise we need to push that to the top of the stack. Push the value. Some index is basically what it is, and we will just self.push index. like that. But we need to actually do index as I32 because that is what it is. And I forgot to do that. And okay, we need to do that as well. All good. And so ident is never constructed. All right, that's okay because we do not use that yet. Ooh, actually, yeah. So we aren't going to use ident at all. Because that is only for lexing, and we do not have that. Because we just use word for that, so that is fine. So let me go to the tokens ident again and get rid of it. Okay, and then I'll compile it. And if I print this out, it should be 0. I'll run test.4. It's actually 10. Okay. Yeah, because it starts at there. So that's not exactly what I want. So what I need to do... Alright, I will just do a vec new for right now. We will adjust. So yeah, it's 0. And then if we make another one, which is just balance 2, sure, and we print out balance 2, it should be 1. It's still 0. Alright, because we never actually push onto there. So when we do that, we need to also push. When we declare it, we need to push 0 onto it. That is what we need to do. That is what we need to do. So we can do that pretty easy. So right here, let me just expand this. So we will push that, and then we'll do self.memoryStack.push, and we are going to just push. We're going to push 0 for now, because that will be the initializing value. And then there we go. Now it is working. So now the value stored at this index, which we don't have a way of getting yet, but it will be 0. And same with this one. It will all be 0. And then we need a way to set and get that. So if we look at how that works, at is to get the value, and exclamation point is, or bang, or whatever you want to call it, is how you actually set the value. Okay, so here's what I'm going to do. I'm going to add 2 new tokens. I'll put it right after here. No, I'll put it after variable instead. Sure. Alright, so what we need, we will have at and bang. Bang. Alright, at and bang. And then, obviously, this will be quite easy. At and bang. At and bang. There we go. Okay, so now they are lexed. Then we can encounter it here. So, when we encounter it, which is going to go right after here. At and bang. Okay. So what are we gonna do here? Indentation got a little weird. Alright, so at we're just going to look in the self.memoryStack. Yeah, we're gonna look at that, the index of whatever we pop off the stack. So let a equal self.pop. So yeah, you could put anything here and it could be out of bounds. So we do need a way to check that. And I don't know if you can actually index them like this. I don't remember exactly. But if I just do that, and we just want to push that onto the stack. But push this. Alright, so let's see. Yeah, so we need to do A as usize. So it could be a problem if it's negative. Which I wonder what happens here actually. If I do 1, 2, 3 and then -1 and do at. No. -1 at. We just get 0. Okay. So if it's out of bounds, we get 0. So there we go. So we get 1. So we don't actually check it. So let's do balance. And then we'll do add. It should be 0. Okay. So we don't have a way to set it. So we need that now. Which is where the bang comes in. So the bang, we're going to pop off the top 2 elements of the stack. A equal self.pop. And then we need B as well. So this is going to be the address. And then this will be the value. So we want to change the value on the memory stack. So at that index. So self.memoryStack. So I don't know if you can reassign like this, but we will find out. So A is the address equals B as usize. No, actually it's not usize, so we don't need to do that. This one needs to be as usize though. Okay. And we get 0. So let's set it then. So let's do 1, 2, 3 balance that. And 1, 2, 3. Okay. And then we should be able to do that as many times as we want and print it out. And it should always be 1, 2, 3. So that is actually perfect. So We can also just change this to be 0, because that is actually what it is. That is inexplicit. And if we set it to 1, it's going to be nothing. It's actually, yeah, it's out of range. We get some errors, so we need checking for that. Yeah, that is quite important. Could do this, and that also doesn't work. Because if you don't declare it, then it doesn't work. 2. Then it will work. Yeah. So yeah, now we can have 2 variables. This isn't how you're supposed to do it though. So 2 and then balance, balance and 2. So we can print out 2 different values stored in there. We could have 7. Whoops, 7. No, 6. Okay, sure. Is that balance? Okay, so we should print out 7 and then 1, 2, 3. I mean 6. I forgot. Okay. So there we go. That is actually working. So there's a couple other operations that you can do with them as well. So yeah. Question mark. Which is prints. So yeah, these are the 2. Question mark, prints. So it is like doing @ and dot. And then plus exclamation point increments the value. So it takes the value stored here, and then adds 1 to it. Yeah, so that should be pretty easy as well. So we need @ and question. Sure. Question, okay, and then we need bang and bang eater. Yeah, I think that is an alright name. So @ and question, bang and plus bang. Okay. Bang eater and that's fine. We need question. Okay, so we can do something like that. And then, so the question one will be quite easy. Yep, which is right here. So it is the same as this, except we also print it. So I think, do we have a function for printing? When we encounter the dot, so we just do that. Yeah, I'll just do that. That's fine. And then I can make a separate function for just self.print or whatever, and it would call that, and then we can use that any other place that we use it. For now, I'm not doing that. Yeah. So that is actually right here that I want to do that. Whoops. Okay, so we push that. Does that push as well? No, it doesn't push. So we don't need to actually even push it, do we? Let me do 1, 2, 3. Balance that. And I need to actually declare balance. Variable balance. And then do that. And then knock that off and do balance question mark. Yeah, okay, so it does not push anything. So we don't even need to do that. We can just do self.memory stack A as user. Yeah, something like that. So if I run this, we don't handle the question one. So I can do that quite easy. Quite easy. Question. Yeah, so I'm not going to actually handle it yet, but it should compile now. It does not. Whoops, because I did not change this. Bang. Wait, bang iter. Yeah, that's what it is. Bang iter. And then this needs to be question. That is my bad. Question. Okay. And then bang iter. Yeah, so it doesn't like that, so I'll get rid of that, and then it's fine. Bang iter. And bang iter. Okay, there we go. And now it should compile. And it does. Okay, so if we do this, if we do question mark instead of this, it should be the exact same output. There we go. And it is. So that is working then. Now we just need the bang iter. Go to bang iter. Okay, so we need to we don't need to pop, we just need to pop off the 1. And then we set this equal to self.memory stack A as usize plus 1. Just like that. And it should work. So now if we do balance plus bang, it should be 7. There we go. And we can do 2 plus bang, and we can do that a couple of times. And there we go. It actually worked. Okay, so I think that's all that we have here. So I am pretty happy with that. So let me go ahead and commit that as well. So basically, added FizzBuzz example and implemented variables and memory. Okay, so I'll go ahead and push that. And there we go. So let's go back into here. Main.rs. So what have we got? Constants. All right, yeah, so we can do that. That is similar to variable, so we can go right after variable. Constant. So I think that can still go in the. We might need a constant stack then. Because yeah, it needs to be something that never changes. All right, well, I will implement this really quick, and then I will do that. Variable and constant. Whoops, it is not like that. So constant and constant. Okay, so let me think about this. So in Gorth, actually, Gorth. So what do I do here? Let me look. So do I have a constant stack? In the stack. Yeah. Where is my struct? Gorth struct. Yeah, so we have constants. Yeah, so we do have the constants. So that would just be another hash map, actually. Rather than a stack, a hash map. So yeah, just another memory map, but for constants. And it's actually the same thing, except instead of a usize, it is just a value, like that. So that should be pretty good. Yeah, so I think we can do that. So now, when we encounter constant, we do a very similar thing. Very similar thing to the bang, actually. So, let's see. So, right after variable, we'll put this. Bang. Alright, so constant. So we're going to pop off this, and this is the keyword. Okay, so we can't actually pop that, because yeah, we want to pop the token rather than the value there. So constant isn't going to push anything. So constant answer. Yeah, so when we encounter constant, we want to get the next token. Yeah, okay, so we want to actually do tokens.pop. And then we also want to unwrap that. Okay, so then we have the name of the constant. I want to put that into the constant map. Dot insert a, and then b is going to be the value that we pop off. So I think that'll work then. I think we need to actually pop front, and something like that should work. Cargo run test.forth, and let's see. So I didn't actually initialize the map. Memory map and constant map. You could comment that. Alright, and we have some issues. Expected string found tokens. Oh, okay, yeah. So stack.constant map. So we need to actually check. So we could match a, and if it is a word, then we're good. So some we just do word tokens word. Then we want to do this. We want to do that like so, except we need to get the name like that. So name. Otherwise, we need to throw an error because it is unexpected. Error unexpected. Unexpected keyword. Unexpected keyword. Sure. All good. And this needs to be a comma. And there we go. So let's see what happens now. It does actually need to be. It does need to be some, right? So if I do that some. Like that. No. Alright, so that's not what it wants. The problem is actually a semicolon, I think. Right there needs to be a semicolon. And then type tokens. Okay, tokens word name. Okay. Wait, so maybe that is not right then. Okay, something like that. And false constant. Where did I do that? In word. False. Yeah, how did this happen? Okay. And it does compile. So let's try to, whoops, let me try to open test.forth and make a constant. So let's just do 15 constant answer. Whoops, 15 constant answer. And it's actually constant, so I don't know why I did that. And then just print out answer. So we don't actually handle that. So it's not going to work. Okay. Undefined word answer. Yes. So in here, we have yet another level of nesting. So basically, maybe there's another way to handle this, but I'm just gonna do this again. So then we just have another thing in here, like this. So we have none, and then we match it once again, but we do it with the constant. And then yeah, so if it is none, we want to pin it. None, then we actually want to pin it. Otherwise, if it is some, and we will get a value. The value, yeah, so the value that we get from that, and then we will just push the value onto the stack. So push value. Something like that should work. So field, even we got get. Okay, constant.get, and need to dereference this, and there we go. We get 15. So it did actually work. So 15, and we can change this to whatever. You can print it out as many times as you want. Yes, indeed. So now we have constants, variables, and memory, all that fun stuff. So arrays are next. Let me commit this. Committee. Alright, so implemented constants. Alright, so it does need a lot of further testing. Yes. And some better error handling. But other than that, it does work. So arrays. So this is just basically allocating space in the memory. Yeah. So, we have cells, which just means one, essentially. It's like doing size of in C. So yeah, we can type out the same thing. So variable numbers, and then 3 cells allotted. So that is allocating on the memory 3 empty spaces. So just pushing 0 essentially, that many times. And then 10 numbers, 0 cells plus bang. Is that plus bang or no? It's adding. So yeah, so it's adding to the address there. Yeah, that makes sense to me. So 10, and then that'll put 20. So this will be the values that are stored in there then. So I can show that variable numbers and 3 cells allotted. And then if we do 10 numbers, 0 cells plus. So this is at the first index. We'll do that. And then we can just print out numbers and we get 10. But then if we do 20 numbers, and then, okay, whoops, I need to actually change this to be 1, and then go back to the 0, make it 10 again. Alright, so then we do numbers at again. We do numbers at is 10. Alright, yeah, so drop and drop. But then we do numbers 1 plus at, and we get 20. So that is sort of how that works. So that is index and array. So we need 2 keywords, allot and cells. Allot and cells. Pretty simple, pretty simple. So, and then after this, yeah. Alright, so add those. Allot and cells. Cells and allot. Okay, so let's do cells first, because that basically is just pushing 1 onto the stack. No, it's just multiplying the top of the stack by that amount. Yeah, which it does depend on the implementation, I suppose. But I'm just gonna do 1 because that's what this does. Because it just depends on actually the size of the memory. In this case, adding 1 is adding to the index, so that is why. But yeah, so we just take the top of the stack and multiply it by that amount. So that is pretty simple. So maybe I could make a constant. Can I just make a constant like this? Constant or const. Const cell width and just set it equal to 1. Is that valid? Okay, yeah. Right, 2. Let me make it actually U8. Okay, and yeah. So that actually is what I wanted to do. So then I can just use cell width everywhere and it'd be easy to change. Even though I'm not ever going to, but I could. So then, down here, I can grab this and we can add those 2 things. So we have cells. Actually, we have allot first, I think. I don't remember exactly. Allot and cells. Let's do cells quickly. So that is just going to let A equal self.top, semicolon. And then we are just going to do self.push A times cell width. Something like that, and that should compile then. So, alright, yeah, so we need to actually do, so with, as I32, that is okay. And it does indeed work, out of bounds. That is because we didn't implement all the stuff. Hey, Schooly B, how are you doing? How are you doing? Alright, so a lot, we need to just, push 0 onto the memory. Alright, so we can do that. 3 cells a lot. So yeah, just for each iteration. Yeah, so we pop off the top of the stack. Yeah, so basically a equals self.pop, so that's all good. And then for let's see, for I in 0 to A, like that. Then we want to, I think I can do something like that. 0 to A, we want to just self.memory stack.push 0. And then that should 0 initialize it. So I is not actually, so yeah, we don't need it. Something like that. So then, yeah, so then they should work, I think. That should work. Yeah. So basically, if I just do numbers 1 plus dot. How goes the project? It is going quite well. Whoops, that's not what I wanted. I actually have most of the implementation in. So arrays, I'm working on that right now. It's mostly done, I think. And then I just have keyboard input and begin until, and then I'm all done with the interpreter, and I'm going to move on to a different project. So let me test dot. I'm not in the right folder, so that is a problem. I'll go run test.4. How are your projects going? I saw that you did, you had some, let's see, it was an error handling thing. Let me actually try to open it up. Yeah, let me pull it up really quickly. I was taking a look at that. Quasar. Yeah. Yeah, testing library. That is what I meant. Yeah, testlet. That is what I meant. Yeah, so this looks pretty cool. I was looking at it a little bit. I would like to try it out sometime. Once I get back to C. Yeah. Quasar. Yeah. It was looking very cool. Yes. And I did start it. Yes. Yes, indeed. Okay. Yeah, so let me go back to this. So I think that it did work. So we have 1. No, it did not work. So, because we didn't actually get the value stored in it, so we need to do at. So we can actually just do a question mark, and that is the same thing. So we get 0, so that is not right. So what is, oh, because we need to change this to 1. So now we'll get 10, and then if we change it to 1, we will get 20. If we change it to 2, we will get 0. Alright, so that is perfect. Yeah, so that is all working. That wasn't very much, like that you could do it without. These are just keywords that make it a bit easier. Well, I guess you do need that a lot. Yeah. So now keyboard input. Let me commit this and then I will do that. Added a lot and cells for array. I'll push that. And let's go. Alright, so keyboard input. So the way I'm going to handle it is the same way I did with my fourth interpreter in Go, where you just scan, just like scanf kind of thing. So I'm not sure exactly keyboard inputs in what. How do you get them? Let me do keys dot rest. Alright, so I don't want a dependency, so just using the standard library. Ooh, and I'm not gonna make it too complicated because it can get pretty complicated. Yeah, so that's unsafe. I don't want to use that. And I don't want a dependency. So what is just a way to get input? Rest read input from user. And then we just get whatever the first key that they pressed was, and then push that onto the stack, essentially. So I can actually add the stuff for that. keys right here, and then down here we can do this, keys. Is it, no, it's actually just key, isn't it? Yeah, it's key, my bad. My bad. Oh, I need to make this key. And up here, I can make this key. And change it in here as well. Alright, so that is what we need to do. Go all the way down here. So, yeah, right here. Key. And yes, that just prints that out. Okay, so now this just print out 1, 2, 3, and then we'll actually, yeah, we do empty the stack, but it does print 1, 2, 3. So, yeah, IO standard in. So let's look at that. So that's what I'm gonna do. So let's try that. That's the wrong place. Just get rid of this, and then something like that. So, let readable input equal string new. Okay. IO standard in read line mute input. Okay. Expect. Alright, so it's just error. Could not read line. And then yes, then we can, I'll just print it for now. But we want to actually print the key representation of it. So I need a way to get that. But input was, and then input. So I need to also just extract the first character from it. So I don't know what it outputs. So I need to actually use standard IO like that. And G. So your input was G, and I can type more than one. So can I just do something like this? Put 0. So what is this? Alright, so how can you actually index a string? Is that something you can do? I don't remember. Index string Rust. Indexing a string is not available. Okay. Yeah, actually, I might want to do. Let's see. So can I do? Not toString. Let me see. So where am I at? Yeah. Can I do bytes? A and 97. Okay. Yeah. So that is actually what I wanted it to be. So then it does work. Here goes 10. It was 32. Yeah. So it doesn't detect like well tabs actually. It does detect, not like control and stuff like that though. But that is what I want. And then yeah, it just takes the first one and pushes that. So that is fine. So we can just push that onto the stack. So we can actually do dot as bytes 0. And we can let so then we don't need the input. So we just need it to pass into there actually. So but we can let key equal that. And then we can do self.push key. Something like that. And so oh yeah, so we can do this as I32. Okay. So actually that doesn't work because I did mess something up. So that's not gonna work actually. Because we need to get it from input. So that is what I need to do. My bad. Equal input. Yeah. And send it going. Okay. And there we go. So if we put A, then it pushes that onto the stack, and we get it. So that is perfect. That is what I wanted. So yeah. So now we can get key as many times as we need. But there's one last thing. And then all the features are implemented. The features that I'm going to implement anyways. Begin until. So we can add those into here. Begin and until. And I will put it right here. So begin and until. Okay, quite simple. So begin until. Okay. Begin until. Alright, sounds good. So begin until it is equal. So this works like a while loop. Every time the word until is hit, the interpreter checks to the top of the stack. So it looks at the top of the stack when we encounter until. So that is going to be a bit complicated, actually, to go back to beginning. So it might change things up. Alright, so let me try this then. So let me write out this code. So print key code. Begin key dupe dot 32 equals until. So that is until till the key code is 0, or is 32 rather. Which I don't know what that is exactly. And then we'll call that. So it's not gonna work now. Whenever you get back to C code, would you appreciate checking out the would appreciate you checking out the lib I'm making and maybe make some issues to help me build it. This is my first time running tests. Yeah, for sure. Once I finish this, actually, I'm probably going to take a quick break from Rust and go back to C, and that is something that I could work on. Is that, yeah. So I would like to do that, and then I'm going to come back to Rust for some more projects. But yeah, so in a couple days, I will definitely do that. Sounds fun. Yes, this doesn't work right now. So we need to do cargo run, and there we go. So we don't handle it anymore. So I can go ahead and do that. Actually, after the loop. Begin and until. Okay. Okay. Yeah, so it doesn't do anything right now. So what we need to do is check begin. So begin. Yeah. So that's going to be a bit difficult. To handle, because we can't just change the index, because we pop it all off the stack. So we need to actually collect, the tokens, and then we can, when we encounter this, we need to continuously do that. So how can we do that? So we do go through one time. So actually, if we go here and we create a variable, which can just be a vector of tokens. So let let's see. So let loop equal vector of tokens. So yeah, vector of tokens. And then, whoops, that's not how I meant to do that. Like this equals, and we will just do this same thing right here. Like that. I'll make it a vector deck because I think I want to use that. And we'll collect until it is until. So then we'll get all of the tokens. And actually, I should make this like this. Just define it up here. Let actually, is that going to be right? Not sure. Let what did I even call it? What did I call it? So loop tokens. Loop tokens. So loop tokens, which is a deck of tokens, like so, equals default, like so. Maybe just actually vector. Okay, something like that, and then here. So we collect that here, and then we have access to it. So we can set it. And then we are still in the loop. But then when we come back here, we want to call it on that. So we just want to pop off the top of the stack. We can just do let a equal self.pop. And then we have that. And then we can just call it on loop tokens. So yeah. It's gonna be it might not let me do this, but let's try it. So self.interpret tokens, loop tokens. So if a is true, a equals 0. So actually it's the other way around. If a does not equal 0, I want to do that. Otherwise, we just want to continue. So I can type there we go. Yeah, so I don't think we need the else then. So if we do that, okay, so if a does not equal 0, then we want to do that. So something like that. Not into. Oh yeah, because we need to do a back deck. My bad. Back deck. And okay, so that's not going to work actually. Oh yeah, so let me not do that, because we already have that. So, where is it at? Where are we at? Right here. Yeah, so I don't need this, because we already know that. So that is okay. And then loop tokens dot clone, yes. Okay, and then assign set. So it needs to be mutable as well. Okay. Mutable. And there we go. So A. And it doesn't work. Okay. So it did not work. That's okay. So what can we do to make it work? We should be calling that, and then we get to until. And it should be stuck on the stack. So can I just do dupe and dot and see what is on the stack that prints out? 0 is on the stack. Okay, so it's false. So actually we need to do it. I think we need to do this the other way around, right? I think that is what it is. Alright, so let me try that. Okay. So then it does it twice. But that is not what I want. So okay, the problem. So dot 32. So we print out the key. And then okay, A. We get 97, 97. Okay. Let me put a new line there. So we cannot do it, it doesn't go more than twice, which is an issue. Okay. Basically we want to go there and then pop off the top of the stack and then check. So if it is 0, if it's false, we call it again. But we need to actually do this. We need 1 extra on this. That is the issue. Because we don't get the until. So how can we do that? Because we don't know what the one after the until token is. Can I just do loop tokens dot push push back tokens until, because we know that we have it there. No, it still doesn't work. So can I print the tokens as well? Let me try that. Loop tokens. Alright. Let's see. And okay, so we get that, and we do have the until in it. Okay. Let's print it in here. Yes, we do have that. But then it becomes 0. So I know why exactly. I know exactly why. Because we initialize it here. Yes. So how can we do that? Suppose we could just add it to the to here, to the interpreter. Should I do that then? Okay. Loop tokens is a vec of tokens. Yes. And then yeah, we need to initialize it down here. Pretty easy. So loop tokens. We don't need the type in there. Okay, and we don't need the equal, we need that. Okay, so we have that. And then we need to do self dot loop tokens instead of loop tokens that we were doing. Whoops. Self dot loop tokens. Self dot loop tokens. Self dot loop tokens and self dot loop tokens. Alright, so let's try that. And let's say loop tokens. Did I not add it? I need a comma. And this needs to be a comma as well. Okay, so let's do A. So I don't know what 32 is actually. So instead of that, we need to do N, because that's like a new line. So A, and then that, and it ends. Alright, perfect. So that is actually exactly what I wanted. So that is working then. Yeah, so it does need a bit more testing, but it works. It indeed works. Where is, yeah, right here. So I don't need to print that anymore. And it should just print the key code every time. And there we go. And it ends. So that's pretty cool. And that was the last thing that I'm going to add today. So the next stream, just going to be cleaning up, adding better air handling, stuff like that. And then that's actually, that's it then. So the next stream will probably be the last one of this series, this particular series. Yeah, but this is all the features implemented. So implemented what? What was it called? Implemented key and begin until. So push that. Oh yeah, so I will be ending the stream shortly. So if anyone needs to say anything or anything like that, now is a good time. All right, so let me just make sure that worked. And all right, perfect. So yeah, also I'm probably gonna write some documentation for it on how it all works. So okay. Looking cool. And so what was the one that they used here? 32. Okay, until you press space. That's what 32 is. I want to try that. 32. Cargo run. Stop forth and space and end. Okay. Yeah, that's pretty cool. Pretty cool. Okay. So I think we are all good then. Yeah, so it looks like nobody is saying anything. Let me see who is streaming right now. Let me see. Okay, later, man. Later. Goodbye. Yeah, so I'm actually going to do a raid quickly. Yes. Just, the only person I'm following that's live right now. Looks like some Go or something like that. Yeah. So, thank you for watching, and I will see you guys next time.